I'm here to talk to you about calcined clay specifically, but for those of you who haven't used the process, a bit of an overview, highlight the aspects of our work that we continue to try and improve to enhance efficiencies and reduce carbon. In-situ recycling isn't a new concept, but a lot of what we do, which is highly technological in terms of equipment and binders, just improves the efficiencies and the way we go about things. So we're constantly developing what we do. The process itself recycles 100% of your road. So our machines run through, pulverize the existing asset. All that material is then reused, mixed with either a cementitious or a bituminous binder, relayed to form a foundation layer on which you can put a surface, anything from as light a touch as a dressing up to a full binder and surface corset over the top. The point is, it's 100% of the existing asset is being re-engineered to enhance the life of that road. The binder addition can be as low as 2%, so we're not bringing much into the engineering aspect. As a result, in terms of traffic reduction, lorry movements, we can decrease that dramatically. You're not taking material away and you're not importing material. All of the material is dealt with on site. So that the example of the lorry movements there is, I think it's a 1 kilometre road, 200 mil deep, about 7 meters wide. You would typically, for us to come in, import some binder, it would be about 17 lorry movements. If you were to take that same volume of material away and replace it, you're looking at best part of 350 lorry movements. Obviously, it's a massive carbon reduction on the disruption around the site, and reduces the wear and tear on the surrounding network as well. The delivery of in-situ recycling generally pretty quick, up to about 4,000 square meters in a shift. So a lot can get done in a shift. So if you're looking at program sensitive carriageways, then it's a healthy solution to get the work in and done and out the way, get the traffic back on the road. We've got a carbon ladder. There's a bit of detail on our stand about this. These are typical materials carriageway use. The blue highlighted ones are where we would consider a conventional recycling. So it's 4% of a binder mixed with the road. The CEM2 is our typical cementitious blend, which comes with a carbon content, an embodied carbon content of 27.7 kilograms of carbon per ton. If we replace that with the calcined clay, the other blue arrow, you're pretty much halving that. Similarly, on our lighter touch, where we're only using 2% of binder, the green arrow, CEM2, sits at about 15.5 kilograms of carbon per ton. If you swap it out for either side, you're reducing it to 8.9. For us, there's three ways we can help you lower your carbon on reconstruction. Either through the materials, the plant itself, more efficient fuel equipment, and increasing durability on your roads. So less visit, less interventions, reducing carbon. We do a lot of in-house R&D, so we are looking at when we sample a road, we take materials away, we do trial mixes in our lab. They're tested depending on what the client's desire on the design front is. It'll either be an HPM that's tested, perhaps a foam bitumen or an emulsion binder. And we will do testing of that material, the actual material we've sampled from the road, so we get a good understanding of what's going to happen when we come to get the machines on site. The purpose of the EVA-Sol really is to replace the cement we use. Cement comes with a high embodied carbon, largely because of its manufacturing process. It's a 1500 degree centigrade rotary kiln. It's combustion emissions, process emissions. It sits there very high. Fortunately, we don't use much of it, but it was an obvious approach for us to look at alternatives to the cement. Having said all that, Cemex have set their own targets. They're currently sitting at 604 kilograms of carbon per tonne for the cement itself. They're looking at alternative ashes, alternative industry byproducts to enhance their carbon credentials, and they're looking to reduce to about 400 kilograms of carbon per tonne. It's not happened yet, but they're doing their bit as well. Our first trial with the calcined clay was in Norfolk, a site in Norfolk about 3 years ago. We used exactly the same quantity of the calcined clay as we would the cement. So in this case, it was 2% mixed through the existing carriageway. So it's a standard in-situ treatment. No additional water, and no reduction in output. So it's just a straight swap for the cement, and it comes with a embodied carbon of 56% of the CO2 that we would typically use on these sorts of sites. All the performance data around the EVA-Sol was favourable and consistent with what we'd expect from the cementitious binders. So there was no detriment in the performance, there was no detriment in the quality of the product we were generating. It was just a straight swap, worked just as well. There will be shortly, I'm told, Helen Bailey of the Driven Company is doing a white paper on this. So we're expecting more customers to take it on. We're currently on a program of work in Norfolk this year, where the entire program is using EVA-Sol. We've now done work for Cambridgeshire, and we're also doing some sites in Dorset who are also adopting the calcined clay. They can see the benefits comparatively. There isn't a huge difference in cost, so it's quite a simple choice to make. Otherwise, we look at reducing our carbon. So I know HVO, depending on the provenance of the HVO, the jury's out as to whether it's an environmentally positive thing or not. But we do have now, in consultation with our plant suppliers, we were worried that some of our Virgo machines might invalidate warranties and that sort of thing. But actually, we're happy to use HVO. If your principal contractor is obliged to, we're happy to adopt that and again reduce our emissions on site. Unlike the machine in the earlier slide, this is the largest machine in the fleet. It works slightly differently. It's a down cut process, so the drum rotates in the direction of travel. It pulverizes and mixes the material, sends it up to a conveyor, and that material, the recycled material, is placed on the road through a paver. Much quicker. Got very high outputs. This is the one that's up at around 4,000 meters in a shift. So if you get this on a busy B road, A road, then we're out of your hair pretty quickly and ready for the surfacing guys to come in. We're all about marginal gains. So this is another new bit of kit. This, nothing more sensational than simply the drum slides from one side to the other. So unlike the four-wheel drive machines, we can only run tight to the curb down one side of the machine. So that involves a little bit of twisting and turning the trainer plant around on site. This negates that and just makes it slightly more efficient on site. If we can save 45 minutes, an hour in a day, then it's increasing the outputs, and again, we're out of here. So in a logistically challenging environment, this is an easy win, really. It's a marginal gain, as I say, in terms of productivity. This case study, there's a little film I'm going to show you, which it's very short, but it gives you an idea of how the larger machine works. We also, because the material's actually lifted out of the ground, we recognise an opportunity to get some geogrid or geotextile or both into the road underneath the recycled material, thereby enhancing its strength. It's a little film, as I say, from Norfolk again, where this was adopted. It'll give you some idea of how the train works and how the grid's installed. Can you play this? No. Oh, there we go.
In this case study, a 2-kilometre section of the B1160 in Norfolk required intervention after the underlying ground conditions caused the carriageway above to be compromised, consequently limiting the ability to carry its usual high levels of industrial and agricultural traffic. To enhance the road's performance and long-term condition, a polypropylene geogrid was mechanically incorporated into the reconstruction below the recycled layer and above the subgrade. Whilst historically this would have meant excavation of the carriageway to lay the grid before covering, SPL have developed a pioneering one-pass technique by using a Vertgens 380 CRI. As the recycling takes place, a section of subgrade below the material conveyor is exposed, presenting the opportunity to roll out the grid before the recycled layer is placed back. The structural benefits of this installation technique helps to mitigate against micro cracks forming within the grid layer and ultimately preserving the integrity of the layers above. With improved efficiency around the grid installation, high outputs of the W3MT CRI, and the re-engineering of existing carriageway aggregates, the scheme is calculated to have a carbon saving of 200 tonnes, equivalent to that of an average car driving 525,000 miles. Highlighting SPL's commitment to managing our environmental impact whilst delivering efficiencies and commercial benefits. SPL, recycling Britain's roads.
So the larger machine, getting the grid in the road in a one-pass operation is a bit of a game changer. It means that you can really add massive durability to a carriageway with not much in the way of preparation. It's all going in as we're recycling. So it's a big bonus for us. We've largely talked about cementitious binders and the Ebrasol replacing some of the blended cements. This is just all our machines now are capable of producing a foam mix. So you just simply hook up a bitumen tanker, spray cold water with bitumen, create the foam, and that gets added into the mix that's created on site. So you're not having to cart it away, create the foam, import, whatever. This all takes place in the belly of the machine. One example of such was Oxfordshire. We did a section of road, 300 mil section of foamed recycled material, just with a double dressing on the top, saving 227 tons of carbon. In this case, that amount of material saved 564 lorry movements, and what they were planning on doing, it saved them 8 days in terms of program. There are other aspects to additions where we have had a significant win is the use of a product called RoadSem by a company called PowerSem. So we found that mixing this through alongside or before we put the cement through helps us deal with poor drainage, shallow clays, or water issues. That picture at the bottom is in Darlington, high water table. They've always had problems, and this has really made a massive difference to what goes on. In terms of the science, I know we've got representatives from RoadSem or PowerSem here who can explain this a lot better than me, but essentially it enhances the performance of the cement, enabling us to work a little bit shallower, a bit stiffer. We tend to shy away from too much cement because it gets too brittle and you can encourage cracking. This just provides a bit of flexibility, which gives us the confidence to use some more cement, resolving a lot of those clay water issues. By creating that stiffer layer on the top, when you get the traffic back on the road, on the left-hand side, you would typically, your traffic's back on the road, it's impacting quite a depth of the material that's in the road. With the addition of RoadSem, keeps everything a little bit shallower, so there's less impact from the lower layers and less damage reflecting on the surface. On one of the early slides, talk about it being a cold process, which means that effectively we can encapsulate any tar-bound arisings within our HPM. It's a safe way of using tar. From us, it's a decent engineering solution. From our client's point of view, it's a massive saving. So Cambridgeshire, for example, when we know we're doing a program of work in Cambridgeshire, they will release stockpiles of material into the carriageways we're about to recycle. And for the client, it's a free tip. For us, it can often enhance what we're doing because a lot of these evolved roads, there's not enough granular material in there. Oxfordshire as well, they've done the same thing. So over a program of work, 35,000 square meters, we managed to lose 6,500 tons of contaminated material, tar-bound arisings from other sites, provided we, like I say, just demonstrate that there's already tar in the road we're importing to. It's a huge benefit. You all know the cost of losing tar-bound arisings. 6,500 tons of it is a lot of money potentially, but it all ended up back on their network, enhancing the strength of their rural roads.